Hello everyone, welcome to my YouTube channel. In my last video, I have discussed about the invertible linear transformation, and linear transformation is discussed in that amount which is sufficient to us. Today I will start a new topic, that is matrix. So let's start with the definition of matrix. A set of mn numbers, it may be real numbers or complex numbers, arranged in the form of rectangular array having m rows and n columns. By m rows we mean that m number of horizontal lines, and by n columns we mean that n number of vertical lines. So this is called, this rectangular array is called the m cross n matrix. On the basis of order of the matrix, firstly I will define order of the matrix, then I will tell you about the how we can divide the matrices on the basis of their order. So, the order of matrix is defined as a matrix having m rows and n columns is called the matrix of order m cross n. That is, the number of rows multiplied with the number of columns is called the matrix of order m cross n. Now, on the basis of order, we can define the matrix into the two types. So, order of matrix, it can be divided into two types. The first one is the square matrix, and the second one is rectangular matrix. Rectangular matrix. Now, what is a square matrix? If the number of rows is equals to number of columns in a matrix is equal to number of columns in a matrix, then that matrix is called square matrix. And if the number of rows, if I name it m, number of rows are m and number of columns are n, and m is not equal to n, that is, number of rows is not equal to number of columns, then we call that the matrix is rectangular matrix. And I will take some examples. For example, if I take this matrix 1, 2, 3, 4. So how many number of horizontal lines? That is 1, 2. So there are 2 rows. And if I talk about columns, 1, 2. These are vertical lines. So 2 rows and 2 columns. So this matrix is a square matrix because number of columns is equals to number of rows, and the order of the matrix is 2. Now, if we proceed for the rectangular matrix, in this case, we take all those matrices whose number of rows is not equal to number of columns. So, if I choose this matrix 2, 5, 0, root 5, 3, 6, then this is, if you see number of rows, 1, 2, 3. There are 3 horizontal lines, so number of rows are 3. But if we see the number of columns, there are only 2 columns. So, and in order to write the order of matrix, firstly we write the number of rows, that is there are 3 rows. So, we will first write 3 cross number of columns. There are 2 columns, so 2. So this is 3 cross 2 matrix. Since number of rows are not equal to number of columns, so we call this matrix as a rectangular matrix. So I hope the difference between square matrix and rectangular matrix is clear to all of you. So in this way we can define, in this way we can categorize the matrices on the basis of their order. Now we will discuss about so many matrices. I will discuss it one by one. Firstly, I will discuss about the column matrix and row matrix because it is very useful in the linear algebra. In order to understand the definition of column matrix, we always remember that in this case we have to take column as 1. That is, the order, number of vertical lines will be 1 always, and number of rows may be anything. So if there are m number of rows in a matrix and there is only 1 column, that is you are getting m cross 1 matrix, then that matrix is always called a column matrix. That is, there should be only 1 column, number of rows may be 1, 2, 3 or anything, but the column will be only 1. So this type of matrix, m cross 1 matrix, is called column matrix. column matrix, where M is the number of rows. Similarly, we can define row matrix. In this time, we will take row as 1, that is 1 cross n, where n is the number of columns. So 1 cross n matrix is called row matrix. In order to write the examples of column matrix, we can take any matrix in which only one column is present. So I am taking a 4 cross 1 matrix, 1, 4, 3, minus 1. So there is only one column in this matrix, that's why we call this matrix as a column matrix. In order to write the row matrix, we have to take a matrix of this form, in which only one row is present and columns may be 1, 2, 3 or anything, but the row will be only one. So if I take this kind of elements, so this will be a 1 cross 3 matrix. So in this way, we can define the row matrix and column matrix. I hope the definition of column matrix and row matrix is also clear. Now I will discuss about null matrices and identity matrix. So our next definition is of about null matrix. So a matrix or an m cross n matrix whose all entries are 0 are called null matrices. So all those matrices in which all the entries are 0, we call those matrices as null matrix. If I consider a 2 cross 2 matrix, that is a square matrix of order 2, and that is a null matrix, so all entries inside that matrix will be 0. So this is a null matrix of order 2. Similarly, we can define a null matrix of order 3, that is 3 cross 3 matrix in which all the entries are 0. So this type of matrices are called null matrix. In order to define the identity matrix, we have to know about the diagonal matrix first. So we have discussed about the diagonals in the class 12th. So in class 12th we will discuss that all the elements that lies on this side, we call that they are diagonal elements. So in case of identity matrix, all the diagonal elements will be 1 and other entries must be 0. So other entries I am taking as 0. This is a 3 cross 3 identity matrix. So if all the leading diagonal elements are unity and other entries of the matrix is 0, then the matrix is called an identity matrix. And if you want to write, then you can write that a m cross n matrix whose all the diagonal elements are unity and other entries are 0 is called an identity matrix of order m cross n. But identity matrix can be defined only in that case when m is equal to n, because identity matrix is a square matrix always. Null matrix is also a square matrix. Now if we define diagonal matrix, so a square matrix, these matrices will always be a square matrix. So a square matrix A, which is of order n, is called a diagonal matrix. If A can be expressed like this: A11, A22, A33 and so on, ANN. Then A is an n cross n matrix in which all the non-diagonal elements are 0. So that is, all the non-diagonal elements are 0. Elements are 0. If we write the example of diagonal matrix, the example of diagonal matrix is as follows. You can take any square matrix. I am taking a square matrix of order 3 in which only diagonal elements will be non-zero, other elements must be 0. This type of matrix is called a diagonal matrix. So we can conclude from here that every null matrix is also a diagonal matrix, because in this case we get all the diagonal elements are 0 and non-diagonal entries are also 0. So on the leading diagonal the elements may be 0 or non-zero, but we have to see the non-diagonal elements. If the non-diagonal elements are non-zero, we cannot say that the matrix is diagonal. In order to say that the matrix is diagonal, we have to check first that all the non-diagonal elements should be 0. So in this matrix all the non-diagonal elements are 0, and also the diagonal elements contain 0 elements, so this matrix is also a diagonal matrix. Now I will discuss about the scalar matrix. The difference between diagonal matrix and scalar matrix is very minor, so let's discuss it. Scalar matrix is also a square matrix. So consider a scalar matrix P is equals to Pij. The suffix I denotes the number of elements in the suffix I denotes the number of row, and j denotes the number of columns, that is in which column and in which row you are taking this element. And this is also a square matrix, so I am taking it of order n. Now if we want to describe the scalar matrix, we can define it like this, that all the non-diagonal elements will be 0 in this case also, that is Pij equal to 0 when I is not equal to j. And if I equal to j, it will be always same, say k. So if I want to write the matrix of order 3, and where k is coming from the field F. As we know that the matrices are always forms a vector space, we have discussed about Mn cross n over F. So the entries of the matrix will always come from the field F. If you choose real field, you will get real entries inside the matrix, and if you choose complex field, you will always get complex entries inside the matrix. So here we are choosing a field F and k is coming from that field. So if I write the scalar matrix, it will always be in this form. I am writing a matrix of order 3. So on the leading diagonal, we have the same elements k, 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 and other entries will be 0. That is the non-diagonal entries will be 0. So this type of matrix are called scalar matrix. We have seen that the difference between scalar matrix and diagonal matrix is very minor, because here we take we can take different elements on the diagonal, but here we have to take the same elements on the diagonal. So from here we can conclude that every scalar matrix is diagonal matrix. Every scalar matrix is diagonal matrix, but converse need not be true, because this matrix is diagonal but it is not scalar, because the value of the diagonal elements is not same everywhere. But converse is not true. Not true. And we have also one conclusion, that every square matrix is diagonal matrix. Every square matrix is diagonal matrix, but converse need not be true. If you choose one square matrix 1 2 2 1, this is also a square matrix, but this is not a diagonal matrix. So every diagonal matrix is a square matrix, but converse is not true. So this was the definition of a scalar matrix. And in my next class I will discuss about type of matrices, that is upper triangular, lower triangular, symmetric, skew symmetric, Hermitian, skew Hermitian matrices. So till then, bye bye. If you like my content, please subscribe my channel. Thank you.